Okay, so so it got stopped when I was telling about the struct type. So basically, the struct type consists of list of struct fields. So that will create you the schema for or structure for your user data frame. Okay, so you take this and pass it to the create data frame has a different arguments you can pass. So one uh, one way to use create data frame is just pass the uh, RDD of your tuples, and also there is another parameter, optional parameter you can pass, so which is a schema. So if we pass a schema, then it will create a data frame with the proper column. Okay, so you can just let me run this. So first this was without a schema, and this is with schema. So it has created um, it has created a column name as ID, name, and city, and also we specified the type as integer. Now it has come the type as integer for the ID column, and the city and the name column it is string. And so we know there is a function called type, which will help you to identify what is the data type of a particular object or a variable. So if you like try to find out the final data frame which we got, which is the users underscore df underscore 11, it gives it shows you that there's a data frame object. Okay. So we saw there are two ways to create a data frame. There is a third way you can create a data frame. So that is creating a multiple row object. So there is a row class in a Spark PySpark.sql package. So import this row class, and you can pass the when you create a row class. Basically, you need to provide the it's going to represent one row. So row is going to have uh, uh, basically a value for each columns, right? So there is a column. This represents one cell value, right? So in your data frame, this represents one cell value. So this might be you can represent basically based on what column you want, the column value you want to represent. You can just think. So I'm just because this I'm going to create a data frame of users. So the first column represents the user ID and this column value, and this is for representing a username. This is for city. So we are creating a row objects. It's not a just a tuple we are creating. We are creating a row object, and so this is for user 1, 2, and so on. So when you have a list of rows, and again you can use the uh, create data frame and pass the list of row objects. So this is going to create a data frame without columns. Without column in the sense, not the with the like default columns, which is underscore 1 and 2 and 3. And again, if you want to have a proper columns, then you can use a schema. So you can actually uh, pass the list of row objects. Sorry, this is actually RDD of row objects, right? Now you can pass the row object. You don't need to convert this into RDD. If we have already a list of row objects, you can directly use the create data frame of list of row objects, comma, if you pass the schema, then it is going to give you the data frame with the proper columns. Any question till now?
Pari, I have a question. How does it know the column names like ID, name, city? Where is it getting passed from?
Yeah, so here, so actually I reuse the schema which I created here.
Oh, okay.
So this uses schema. So since I'm using just the same uh, data set, I'm just using the same schema which I created in this cell.
Okay, got it. Thank you.
No problem. So yeah, so that's what here. So this is the option 3, and option 4. So basically, if we have a list of dictionary objects, right? Um like when we say dictionary, basically it's a kind of key value pairs, right? So if you have a list of dictionary, so again I represent ID as a key, value as the one, and ID as a key as the ID and value as one, and another key as a name and value as John, and city as a key and the value London as a value for the key. So this represents one user information in the form of dictionary. So if we have a list of dictionary objects, uh, with this also we can create a data frame. So again use the Spark session object dot create data frame and to pass the dictionary, list of dictionaries. So again this is going to create a data frame. Okay, and if you look at this, if you pass this, so since it has key, okay, so this is going to be considered as a column, and this is the cell value of that particular column. So this gives me the data frame with the columns, but thing is the order may not be uh, whatever the specified in this. So you have a city column comes in the first, and you comes the ID column as a second and third as name. So it depends. It is not. We are not. It will not sure that it comes in a same order you pass it. So for that, we can actually use a schema, right? Yeah, so we can define a schema and we pass it. So anyway, the user schema is we prepared in the above steps. So I'm just reusing it. So this is going to give me the proper ordered data frame. So ID, name, and city. Okay, so these are the different ways to create the data frame programmatically. Okay, now so we saw how to create these data frames. Now with programmatically, then next we will focus on how to create basically this. Okay, so next we will create how to create a data frame using a file sources. So we'll see JSON, CSV, JSON, and also I will show you. I don't know whether I have Parquet file. I'll get a Parquet file tomorrow. I will do that. So today we'll see how to create a data frame using a CSV file and a JSON file. Okay, I'll run this. So we have again, I'm just for the simplicity's sake, I'm just using the same data, the user information, but I kept it in a file. Okay, so if I go and open the file, this is the user details in the comma delimited. See here, you have the comma separated values, user ID, name, and city, and so each row represents each line represents one row. I'm going to represent that. Okay, so this is kept in this location. So you have to provide your file location. I just this is my file location of my CSV file. Okay, so since this is a Linux path, so I'm just using a file colon file colon / followed by the path. Okay. So if it is an HDFS, we can use the just a slash. Okay, so then okay, now it's very interesting here. So Spark session object has a function called read and then dot CSV. So it has a API for reading a CSV file. So what you need to pass is a path of your CSV file, which is going to give you the data frame. So this is able to read the CSV file and convert your CSV file content into data frame. And if you see here, again you get a data frame with the columns and rows. So only thing is we see it basically it is also considered first row also or the data. So we have to instruct that the first row need to be considered as a column. Otherwise it will take that also data and it creates default columns like underscore C01, C0, sorry, C underscore C2, C1, C2 like that. So again, if you want to mention that what is the delimiter, there is a property called SEP, separator, and specify the delimiter. But since we have a comma delimiter in this file, so we are using comma. And you need to make another property which is header equal to true, which will consider first row as a uh, column values, means the column header. Sorry, first row it will consider as a header and that will be used for creating a column in data frame. So let me run this. See this as columns like this, and if you pass separator and header equal to, so you get a column. So the proper columns, right? And if you look at the schema, the columns are proper, and also you see this all the columns are string. Okay, so there is a either you can actually create a schema and pass it to the CSV method, or there is a one more property called infer schema. So it will you will actually instruct the CSV API to go and refer the CSV file, and then based on the values in a column, means values in the file, you infer the columns for these. You infer the data type for the columns. So for that you can use a property called infer schema. So that will make your column, the first column as kind of integer value. So it will make it as integer. So this properties also will be useful. Okay, so and there is one more file which having a delimiter as pipe. So this one. The same CSV file, the only thing is it has a delimiter of pipe. So if you have like that, so you need to instruct that the delimiter as pipe. Remaining everything is same. And then, so if you don't want to use a infer schema property, rather you want to specify your schema, which is like creating a structure for your file. So how do you create a structure? So we know that. So either you can specify you can import the respective classes in Python, right? In Python, if you are importing a package, you can like do like this from PySpark.sql.types import star. So star will import all the classes under this particular package. And then this is the way we create a schema for our file. So this we already used in the previous example also. So we have a user, we are going to create a struct type of multiple struct fields for user ID, name and city. So then you pass it. There is a property called schema and you pass your schema of which you created. So it's going to give you the same data frame. Okay, so once okay, all right. So we will take another example. So there is a file called CSV transaction detail.csv. You open this. It's basically purchase details of the particular e-commerce website, not the one specific website. Basically, how many. It's basically the transaction or purchase details of different e-commerce websites. So it has transaction amount, card type, uh, uh, the the purchase happened on particular e-commerce website, and country and the city, yeah, city, and what is the product it purchased, and how much this is order. Transaction ID is there. The quantity is not there, but the amount is transaction amount was there. Okay, so we will read the CSV file and we'll do some data frame operations. So again, reading a CSV file is looks to be simple. So we just spark session object dot read dot CSV and pass the path of your CSV file. Yes, we have a header in this file, so we use header equal to true, and we infer the schema. So and if you want to just know how many rows in this data frame, you can use a count. There is a function called count. Okay, if you do that, it is going to give you the number of rows in this data frame. Again, show we know just to display the I'm sorry. So show function will help you to display the content from the data frame. You can pass if you want to restrict list of rows, you can provide the integer value, and followed by there is a property. So basically, if you don't give this, it will truncate the value which is going to display on the screen. Okay, so so if I'll just remove this and show you. So it will be like if you have a big value, it will be dot dot dot, right? So just to display on the screen. So to enable truncate if you enable truncate false, it will show you the entire value. If you don't use this, I'll say df dot show of 2, and let me run this. Here it's not uh, having any probably that effect, but if you have a bigger column values, then it might be truncated, like saying dot dot dot. So to avoid that, you can use this, and it has 1,000 rows. Okay, when we perform a count operation, it says 1,000, and we have a filter, right? We have a filter, and you can pass the expression, condition as a expression here. So data frame dot filter and the column name. One of the column we add is basically a transaction country name. You can just only get a transaction which is made from USA. You can say transaction country equal to, in a single quote, specify the value, and this is going to return data frame, and then you can use a um, show function to display the result of that. Okay, so then there is a one more. Okay, so this is just to applying a filter. So if you want to aggregate, if you want to perform some aggregate operation, how do you perform it? So I want to perform aggregate based on the card type. So I just want to find out uh, the total amount is spent on the different cards in the table. I mean, table in the sense in the data set. So I just want to, there is a two distinct cards only. So Mastro and Visa. Um, so the so you have to do is data frame dot group by. You have to provide the column on which you want to perform the group by, so which is a card type. And there is a function called dot ag, which is aggregate, represent aggregates, and you specify you this uh, sum is the aggregate function we are applying, sum of the column name, and it's going to return you the column name as sum of that transaction amount. But I want to make it as a column name as total transaction amount. Just I'm using alias. Alias is basically you're going to change the column name. Basically, okay, so I will tell you. So basically, it will give you column name, or I'll just run this with. If you don't provide this alias name, I'll run this. So it gives column name as sum of transaction amount. I don't want to like this. I don't. I want to make this column name as total transaction amount. Then what you need to do is this is you apply that transformation, right? Dot alias of you give the new column name. So that will give you the proper column name which you want to.
What is that dot AGG?
Dot.
AGG.
Yeah. So
Sum
basically,
is
yeah, this is the basically if you want to apply the so
sum function.
yeah, so basically this will give you the data frame of grouped objects. So if you look at this, actually this we can put it in two different ways, two different things also. So this is going to give you,
That complete data frame.
sorry,
I mean, that will just group the transaction ID type.
yeah, yeah. So on top of that, you apply this group.
And I am asking that aggregation is required, only sum is not enough.
No, not enough.
So sum is inside the aggregation class or something.
Yeah. So basically, it has to be the sum, the aggregation function has to be applied by using the aggregate.
Do we have any other like count, mean, max, or fact?
Yeah, yeah, we have min max everything. So you can just go to there is one more place. All this, some of these functions you can apply. So you can apply mean, min, max is there normally. You can find a month. If you have a date column, you can find a month, other stuff. Okay. Is there any other question you have?
But AGG is a class or what you can call?
AGG is basically you saw here, right?
So sum is a function, AGG what you can call the name.
This is a group data. On top of that, compute the aggregates, returns the result. So actually, it takes the list of aggregates via AGG. See, AGC is applied on the group data. See, whatever you perform here, this is going to give the group data. I'll just show you this also. Right, so it's going to give you the group data. This when you apply a group by to apply the transformations. Sorry, the aggregation on top of this group data. You need to use that aggregate function on group data. That's what is mentioned here. So example, if I do like this, let's go here and say data frame.
I want to get complete sum, sorry, without aggregating like total transaction amount, irrespective of a card type. This is
If you want to do without grouping, you have to do like this.
so it will be one record only, right? Short and doesn't, I mean, make any difference, right?
No. Because there's no group, right? So it's basically the entire sum.
Okay, yeah. So select is
Select is basically a API or function. It's kind of select class for your table
okay.
query.
Okay.
So this is my data frame. So if I want to select respective columns, I can use a select class. It's a select class in your normal SQL query. You can think.
Okay. Okay. Hmm.
So Spark SQL it's more of a SQL developer. You can just correlate your SQL thing into Spark SQL. So it's going to be more of uh, just you have to relate to that, and then it's almost you are there. If you already have SQL, then Spark SQL is going to be uh, a little easier. Okay, so this is to represent, create a data frame using a CSV file, then we'll see JSON and we'll close up for today's session. So I'll open this. I'll just create a Spark session object, and before that, okay, sure. There are, I have a JSON file which is in 3 different formats. So one is user details.json. Okay, this contains JSON like JSON structure. In each line represent one JSON, which represents one user information in a JSON structure. So like this. This is one way of representing a JSON file. The other one is multi-line. So same JSON, but it is in multi-line. It's kind of formatted, right? This format. And the next one is same multi-line with which will be inside your array, which is in square bracket. So mostly, if somebody is sending the proper JSON file, ideally it should be in this format. Okay, so always, if you are actually having only one element, okay, say example, I am just having user, I'm going to hold the JSON file for a particular user, then just this representation fine. So if my JSON files going to represent multiple user information, ideally it should be in square bracket, and each field should be separated by comma. So this is one of the valid syntax for JSON. But sometimes you may downstream system or the other system may not send this format. Say example, if they send it in this format or this format, how do you process it? The one which we are going to see it. So first we'll see if somebody sends the JSON files like this. Okay, so for that you can just you can directly, okay, I'm just again I'm just creating a schema which we saw already, same user information only. So is again reading JSON file is going to be spark.read.json, right? We add a Spark session object .read.csv. Here we have a .json, and you pass the path. So it is going to read the JSON file and give you the data. And then, okay, so if I do the, it's a multi-line format. If I use normal JSON, it throws error. It says it's not disallowed and just corrupted kind of thing. Name says corrupted. Okay. So if you pass there is a property called multi-line equal to true, then it is going to consider. Again, it is not actually taking all the records. So if you look at this, actually we have all this information. We have a 5 user information, but it's only picking 2. Sorry, only picking 1 record. Okay, so it has to be in the list format. If you want to providing a multi-line, it has to be in the square bracket. So if you read this, the third file, it is going to read all your records. And again, if you want to have the proper structure, you can also pass multi-line true. You can also pass schema of your user. Okay, so this is just providing a path and the multi-line true. And if you want to specify the schema which you defined earlier, you can also pass. So these are the different way to read a JSON file and create a data frame. Any question in this?
No, Pari. Very good.
Okay, so probably with this I will stop it here. There is one more. So if you have a nested JSON, how do you process the nested JSON? So we will see tomorrow, because say example, if you have a file like this, right? So this is the JSON, and this is the key value base. There is a key called data, which again has a list of JSON objects, right? So how do you process this data? We will see in the next class. So so we need to do some techniques to pass this data and convert this into data frame. Okay, so we will discuss tomorrow how to read a nested JSON file and create a data frame out of it. Okay, so that's it from my side. Let me know if you have any question.
No questions for me.
All right. Okay, so then I will actually upload this both the videos and also all this the data files. You can actually go through it. Thank you so much, friends. Bye.
Pari, one question.
Yeah.
Is it possible to share the GitHub link which you mentioned
Okay,
yesterday?
so yeah, so I will do it. I will do it today. So I was thinking that, yeah, I will create a Git repo and Git. Okay, so I will create a public repo. Okay, I will create a public repo. Okay, sure. I will do that today.
Okay, thank you, Pari.
No problem.